Yeah, I'm going to talk about what I call, I prepared this bespoke presentation on futuristic insights into bio neuroscience. And I'm going to cover a number of issues like sensors, biometric sensors, predictive eye tracking, human enhancement, the issue about genetic editing, sensorial life, ingestibles, nootropics, which is something that Professor Kindi should know a lot because it's from the pharmacy side, optimization neuroscience, chemical haptics, augmented humanity, the science of intelligence combined with artificial intelligence, and of course, neurology and foresight as well, and a number of other topics I'm going to cover. Blue brain, three major brain projects, blue brain, a human brain project, and of course, the American Connectome project. And of course, the future, I'm going to tackle the issue about singularity, cognitive dust, the issue about the human machine, mind machine, the difficult problem to crack, which is the neural code. We are entering the age of bionics, part biology, part machine. And of course, this is really the inception of transhumanism, super intelligence. And of course, we might actually have advances in what we call neuromorphic chips. So that's more or less. I apologize for putting this cover of my new book, which will come out very, very soon in the States. On the right-hand side, Biometrics, Neuroscience, Research Applied to Business and Management. So in terms of biometrics, there's a huge amount of sensors and huge amount of gadgets that everybody knows, from voice recognition, facial recognition, emotions, the issue about galvanic skin response, hand recognition, palm, gestures, retina, even walking, the gait recognition, heart rate variability. We've got the incredible amount of biometric sensors, and this technology is more and more advancing, hopefully to create convenience and to the benefit of people that use wearable tech. No, it's no doubt that a number of these wearable tech devices can measure emotions, either being the gaze tracking, eye tracking, visuals, the heart rate variability, all that are linked with emotions. Even some of my research dealing with voice speech analysis, or if you will, utterance analysis, which is more or less the issue about sounds coming out of your mouth, that also is related to emotions. This is just one example, a very basic bracelet, Q sensor, a company called Effectiva, which measures skin conductance, which in turn is related to emotional arousal, positive, negative. So again, based on GSR, galvanic skin response. But there are more advanced biometric trends, like having a digital tattoo or a biometric tattoo, which can actually come up with components that will able to monitor stress levels, temperature, heart rate, how hydrated you are, etc. And you can actually give you feedback on these physiological functions. These digital tattoos are patched in the skin, measuring your vital signs. And especially nowadays, with developments of 3D printing, circuit printing, flexible electronics, materials, you can actually have that electronic tattoo on the screen for a few days or even for weeks, if possible. Skin input is another technology, is an input technology that uses bioacoustic sensing to localize tapping, finger tapping on your body and on your skin. So you can actually use a pico projector, and the device can provide a direct manipulation, a graphical user interface on the body. All these are pretty much novelties in terms of biometrics. So it's a kind of physiological surveillance. And you can analyze, if it is either the five senses, if it is hearing or eye, etc. For instance, how many words can you actually capture per minute? Obviously, the eye can actually capture up to 2,500 words, whereas the ear can only get about 125 words. All these can measure your abilities, your capabilities through biometric sensor technology. Eye tracking, again, is becoming very, very important, especially in terms of predictive eye tracking, gaze tracking to analyze. It's very important because you analyze the gaze and you are able at the end to create what we call ICA, an index of cognitive activity. And that is very important. So you can predict emotions through the micro expressions that are in this triangle between your nose and your eyes. Some companies like NVIDIA, very, very important company in California, has actually used facial recognition, but in a very, very sophisticated way. They're using neural networks, hidden layer. The first one extracts all possible low-level features like lines, edges, contours, and the next layers are more abstract and deal with more complex features of possible relevance in terms of your micro expressions through facial coding. A number of applications. I mean, in China, KFC is testing. You can pay through your smile. The 3D camera, a special algorithm, can do that. That is very convenient. Metro Bank in England, in London, allows customers to open a bank account by taking a selfie, obviously measuring eye tracking and also facial coding. Zurich Insurance Company, can give you a quote for a new insurance, and also all sorts of personalized financial information based, again, on a selfie, mostly in terms of facial coding, facial recognition. And of course, it's everywhere, as you know, cameras and people actually being monitored through facial recognition, etc. And this gives a lot of information, should be with consent, should be not an invasion of privacy, but should be with consent. And we need to be very careful about privacy and about data containment, and really the issue about data regulation. But also there is biohacking. Nowadays is incredible the amount of biohacking. All this that really want human enhancement, those that call themselves transhumanists, are having a number of technological breakthroughs like biohacking, which are springboards to healing people and even maybe to improve humanity. And that is quite incredible, because transhumanists predict that a convergence of these technologies will allow people to control and even to change their minds and their bodies, especially their body at the moment. But for that, you need actually to deal with genetic engineering, genetic editing. So finding the blueprint for life, and of course, being able to decode and to read that, this has created an opportunity to change human physiology at the most fundamental level. So by manipulating genetic code, we're talking about genetic engineering, you could allow scientists to produce people with stronger muscles, harder bones, faster brains, etc. Biohacking is actually appearing, and you can actually, through biohacking, literally be able to modulate, for instance, your immune system through someone else's, the gut microbiome. So your gut microbiome is a vast community of bacteria, fungi that inhibit every nook, every cranny of your gastrointestinal tract. And this has influence on your metabolism, body weight, illness, immune system, mood, appetite, etc. And there are a number of biohacker labs already in operation. So it's a kind of a citizen science dealing with the sequencing of microbiome, your microbiome, incredible. But this is part of what we call sensorial life. But in the future, our bodies will be radically changed by biological and machine-based enhancements, biohacking, but the fundamental sensorial life, that part of us that touches, that hears, that sees the world, that will remain intact, according to my perception. There are ingestibles as well, are broadband-enabled digital tools that we actually eat. For example, there are smart pills that use wireless technology to help monitor internal reactions. And I don't know if Mark Kindy is there, but it will be good to have a comment from him in these areas of ingestibles. And also some nootropics. The future of the human brain also is the use of smart drugs and nootropics. We are on a quest to achieve the next level of humanity. But the idea behind nootropics is not to taking a pill, a magic pill, and transforming yourself into a genius. Certainly not. The core value is optimization. We're dealing with optimization neuroscience. Some companies like, and some researchers like academics, University of Chicago, is now experimenting with chemical haptics. So sensations, simulate different sensations. For instance, capsaicin can be used to simulate warm, heat, whereas menthol does the opposite for simulating coolness. Meta as a company and their research on microfluidity processors and tiny, very tiny sensors woven into gloves may be a bit more realistic than chemicals applied to the skin. It will be interesting to analyze what Reality Labs will come up with, very close to the work on the metaverse. There are also contact lenses, smart contact lenses that give you almost superhuman vision. The University of Washington in the Pacific, Samsung is dealing with that. This company, Mojo Vision, is actually working on that combined to do these well beyond virtual reality, to do these smart contact lenses. So are we dealing with a shifting paradigm or a hype? Well, having more energy, having more intelligence or stamina is not the end point of it, the enhancement. Many transhumanists say that, but some futurists like Ray Kurzweil talk about the use of machines not only to dramatically, incredibly increase physical abilities, cognitive abilities, but to fundamentally change the trajectory of human life and experience. Kurzweil predicts that by the end, in about 15 years from now, the end of 2040s, 25 years from now, the first people will upload their brains into the cloud, living in various virtual worlds and avoiding aging, maybe evading death as well. Also, very interesting the work on neuroscience combined with virtual reality, advancing virtual reality technology and leveraging the brain's visual auditory systems. So these interactions, brain-body, to immerse users in virtual environments is actually quite enticing. However, there's a huge untapped potential in this cross-fertilization of technologies, neuroscience with virtual reality, and of course, pretty much a new frontier of brain research. The deployment of neuroscience research to drive greater immersion using virtual reality, augmented reality, blended reality, as well as the use of virtual reality in research to further our understanding of the mind, our understanding of the brain. And the metaverse is actually a good example. Meta, the company, believes that their haptic gloves, virtual reality haptic gloves, could unlock the future of the metaverse. Their engineers, at Meta have developed a number of, prototypes to tackle this goal, and they include also haptic suits that can feel, they can touch, etc., that could enable real-time sensations. Just wait and see. And that is actually advancing quite fast. So, but we also need this scientific environment to draw attention to the importance of making neuroscience accessible to citizens and to improve their daily lives. And that is very important. And compare all the time. For instance, you can actually have questionnaire self-reporting research to analyze the mood, the degree of happiness of people. And then, of course, combining with some technologies, just by using basic electroencephalography, electrodes implanted to people's brains can detect signals and transform into information about the mood, their state of mind. And that is actually a number of studies show these predictions are pretty much converging with self-reported reports, self-reported questionnaires. So we are entering the science of intelligence, and also, of course, combined with artificial intelligence. Maybe over the next 50, 100 years will come from the science of intelligence, that from neuroscience, computational neuroscience, this will be the two main building blocks of the science of intelligence. We can have a glimpse, in terms of theory, in terms of experiments, how well circuits of neurons compute abstract concepts, or more precisely, how circuits of neurons create programs, routines that underlie human abilities such as language, reasoning, and development of mathematics, science, etc. Also interesting the work in terms of neurology and foresight, to explore these connections between neurology and foresight as a cross-disciplinary discussion. Of course, we all know there is definitely an episodic foresight, identified as the primary neural mechanism that allows humans to construct images of the future, providing further power to define and to comprehend and understand the processes that invoke future studies and foresight activities. A top-level framework making more explicit this process can identify brain functions as well. Opens to experience, preference in terms of time, temporal preferences, as the primary process that inform the building up the construction of new images. So factors involved with these constructions, we have brain functions, episodic foresight, creativity, emotion, either, amygdala, prefrontal cortex, and this take into account the framework, temporal focus, past, present, and future, and openness to experience. We are able to create image of the future, and the future and foresight studies process in terms of identifying and anticipating assumptions. That is very interesting and can come from this intersection with neuroscience. So neural network models of the future also are a very important element to unlock how our brain works. So we need to bridge the gaps between approximate human brain models at different levels in order to understand the brain functions in full. So understanding at the microscopic level, the nerve cell functions in terms of neurons, roughly at the micrometer scale, the mesoscopic level of interactions in terms of local neural clusters, millimeters, and of course the macroscopic level, visible to the naked eye in terms of centimeters. And there are a number of 3 major projects in the world dealing with all these work in terms of neuroscience. Blue Brain, based in Lausanne in Switzerland, is the objective is to establish simulation neuroscience as a complementary approach alongside experimental neuroscience, theoretical neuroscience, clinical neuroscience, to be able to understand the brain by building the world's first biological detailed digital reconstruction simulations of the brain. They're using synthetic neurons that can be much faster than biological neurons. The supercomputer simulations and the reconstructions built by this particular project, Blue Brain, offer a radically new approach for the understanding of the multi-level structure and the functions of the brain. We're talking about, a project that finds how neurons form billions of synaptic connections. So incredible, these cutting-edge research infrastructure that allows, scientists and also industrial researchers in the fields of computing, neuroscience, and brain-related medicine to work together. And more, and of course, this human brain project actually intertwines with artificial intelligence. They characterize brain regions using machine learning. And of course, you can see that more or less. I mean, if you then they pass on to you this presentation, this PowerPoint, you can have connectivity, observations. You can actually deal with these inputs in terms of region-specific parameters, surface-specific parameters, have a dynamical system, and of course, a common input coming from the brain. And you've got the node dynamics, and the node dynamics are really the important element here in the generic model of the brain. This is part of the framework of one of the frameworks that the Blue Brain uses. The human brain. What is the connectome? The connectome is actually, human brain is in Zurich, also in Switzerland, and the connectome is United States. No doubts that the human brain is a very complex, dynamic biological network. This connectome, the connectome itself provides comprehensive maps of the structure of this connectivity within the brain to better understand the functional relationships of the brain. So we have a long way to go until a nanoscale connectome of the whole brain can be actually achieved. The brain has about 1,015 connections and around 100 billion neurons, so roughly as many stars as the Milky Way. So clearly everybody has to accept that is the most complex phenomenon known to science is the brain. So a typical adult brain contains about 100 billion nerve cells, neurons, but a single neuron can be linked with axons, output wires, dendrites, input wires across synapses, gaps between axons and dendrites, to as many as 100,000 other neurons. So if you crank the numbers, you will find that the typical human brain has quadrillions of connections among its neurons. So this human connectome project actually over a transatlantic collaboration venture, really is aiming at creating a structural map of the brain. Very complex neural network that we have. This project started in 2010, whereas, for instance, the Blue Brain 2005. And our knowledge about the structure of the brain and the way it functions has increased because of that. Although there's still a long way to go towards the mapping on a nanoscale connector of the whole brain. So what next? Well, we are living in a paradox, as the achievements of artificial intelligence advance are shaping human ecosystems. More dangerous, more valuable, we have to decide than ever before, but promise or peril prevails, will define and will determine the future of humanity, of all of us. And that's, we are talking about singularity more and more. Machine intelligence, artificial intelligence will actually superimpose and actually overtake human intelligence. Well, we have an exponential rate of artificial intelligence technology, no doubts about that. We are reaching the point, the revolutionary point, turning point, known as the singularity point, where, predict that we will be able to enhance human intelligence, magnify creativity, entering also a stage for mankind, a new epoch for the cosmos. But technology advancement is actually doubling every decade, if maybe even less, doubling or every 5-6 years. And that is incredible. So we need to enhance and to improve the issue about human intelligence to respond to this exponential rate of technological progress. So brains as computers. Again, singularitarians insist that brains are just complicated computers. There is some basis for this analogy. Neurons resemble transistors, yes, absorbing, processing, re-emitting the electrochemical pulses known as action potentials. With an amplitude of 1/10 of a volt and the duration of 1 millisecond, these action potentials are remarkably uniform and they do not dissipate when they are zapping down axons a meter long. These are also called spikes, a reference to their appearance when you are using an oscilloscope. Action potentials serve supposedly as the brain basic units of information. Action potentials. And that is incredible because we might actually, with the singularity, are we going to turn into cognitive dust? Many singularitarians action potentials are equivalent to operations in a computer. If the brain contains 1 quadrillion synapses processing on average about 10 action potentials per second, then the brain performs 10 quadrillion operations per second, or if you will, 10 petaflops. So some supercomputers have already surpassed that processing rate. So singularitarians believe that computers will soon leave us with their cognitive dust. Unless if we embrace through bionic convergence or upgrading, we need to respond to this technological advance. Or are we, reaching singularity may be the humanity's greatest and maybe last accomplishment. So some experts think that it is unclear where there is something special enough about human brain ability to process all this information and cast doubt where artificial intelligence can actually surpass our abilities as human beings in relevant areas, especially in terms of consciousness. Maybe there is something unique to our biological brains after millions and millions of years of evolution that computers are not able to achieve. So if not, singularitarians are correct, and reaching singularity could be humanity's greatest and last advance. Amongst all of these technological advances, under development, one of the most frightening and fascinating ones are BCIs, brain-computer interfaces. They are fascinating because we still have so much to learn about human brain, yet researchers, scientists are already able to tap into certain parts of the brain. And they are frightening. These are frightening because BCIs, create possibilities to come being able to influence, to read, even to hijack people's thoughts, the thoughts that each one of us has. But the worst case scenario that we've been played, in terms of, we've seen in science fiction, are the other side of the coin. maybe BCI's brain-computer interface could also be a tremendous benefit to humanity. And we can create, can manage, and if we can regulate them correctly, ethical behavior and verifiers, integrity, artificial intelligence integrity, neuroscience integrity. So, but no doubts that more and more we are moving towards merging the brain with technology. Elon Musk has a company, Neuralink, and trying to create brain implants, etc. There are a huge number of startups that are appearing, Kern3, BIOS, creating an interface between human nervous systems and artificial intelligence. Another one, which are quite likely quite new, although we don't know much about their work, is Nectome. But Nectome is a research organization dedicated to advance the science of memory. They are trying to design and to conduct experiments to discover how the brain physically creates memories. So beyond the hippocampus, so to beyond these, mental files, to develop biological preservation techniques to better preserve the physical traces of memory. So that's very incredible. The idea is that the brain can store, at some point, can turn into being a computer hard drive. They can store data that can be read. So, of course, we are concerned, and there are critics about singularity, but mostly about secondary singularity, where human expertise declines. As we are seeing more and more technological advances, human expertise will decline. And of course, we are concerned. It's a company, they are actually, you remember that several months ago, over 1,000 experts in the world asked organizations to reduce their support, to reduce their advancement, especially in terms of GPT-4, beyond GPT-4, etc., in terms of large language models, artificial intelligence. So try to be careful when you are building smarter machines, but create machines which make humans smarter. But mind machine is very interesting this year. It's a natural beginning of singularity. Lots about that, because they actually combine mind and machine in a way no other technology has done so far. So if we want brain-computer interfaces, we must first decode the brain. And for that, we need to use cryptography. Neuroscientists are translating brain activity using neurocryptography, which is a branch of cryptography dedicated to analyzing the application of what we call stochastic algorithms, especially artificial neural networks, for the use of encryption and cryptanalysis. So this is probably one of the most challenging jobs that we have. The neural code is science's deepest, most consequential problem. If researchers can crack the code, they might be able to solve this ancient, philosophical conundrum as a mind-body problems, or the will of the free will. A solution to the neural code could also, in principle, give us unlimited power over our brains, over our minds. So singularity and the neural code. So this bionic convergence and psychic uploading will not be possible unless we are able to crack the neural code, which is the science's hardest problem. A solution to the neural code could, in principle, give us this power, as I mentioned to you before, over our minds, over our brain. So incredible. Mind control, mind reading, bionic enhancement, and even psychic uploading can actually become a reality. But for that, we need to analyze as well which are population codes and temporal codes. Some neuroscientists suspect that temporal codes predominate in the prefrontal cortex, other brain structures associated with what we call higher cognitive functions. For example, decision making. In these regions, neurons tend to fire on average 1 or 2 times per second. On a more macro level, researchers are seeking to find out population codes. Population codes are very interesting because they involve correlated firing of many neurons at the same time. So these BMI machine-mind interfaces are clearly a challenge to what we call the moment of singularity, as we see it as Ray Kurzweil mentions. So he predicts that artificial intelligence will equal or even surpass human intelligence in the not very distant future. Some people say 10 years, 15 years, some people say end of this decade. And this will be the moment of singularity. So advances in BMI, brain-machine interfaces, may be viewed as a challenge to futuristic prediction. They strive to instrument human brains with unlimited memory, calculation, communication ability, which then will provide a competitive edge to human brain power versus artificial intelligence. So that actually can benefit us over the advancing technology. So age of bionics, clearly we have arrived at this new epochal moment. The next great leap for the universe will be when humans and technology actually merge. Nowadays, we already have 85% biology, 15% technology in some human beings. You can have nanobots traveling to your arteries. But we're not talking about, just finding Google Maps or whatever. We're talking about technology that will be enmeshed in your biological makeup. The age of bionics. As such, the machines will make us to transcend human brain limitations of a mere understood trillion extremely slow connections and overcome age-old human problems and amplified creativity, human creativity, and could be the next stage of humanity with silicon in our brains and titanium in our bodies. So artificial intelligence-based enhancement and transhumanism. So incredible, because again, some people say maybe it will be commonplace in 30 years from now, 50 years from now. Some people raise doubts concerning where radical artificial intelligence-based enhancements, transhumanism, advocated will accomplish the transhumanism goals of longevity, human flourishing, and enhancement of your intelligence. So it's a big debate that we have in terms of transhumanism. Singularity. So are we becoming transhumans, superhumans? Singularity is defined as the future period during which the pace of the technological change will be so rapid, its impact will be so deep that human life will be irreversibly transformed. So keeping up with superintelligence. Now, there are those experts that believe that overcoming artificial superintelligence, because at the moment we are dealing with narrow artificial intelligence. Then we're going to have general artificial intelligence. And then we're going to have the end super artificial intelligence. To overcome artificial superintelligence, there are a number of methods, of course, that can enhance human intelligence, create a superhuman with superintelligence. In theory, I'm going to use what? I mean, I'm going to use augmentation, human brain augmentation, intelligent augmentation, to advance in bioengineering, genetic engineering, nootropic drugs, mind uploading, even in terms of BCIs, brain-computer interfaces, or all sorts of virtual artificial intelligence assistants. The reality is the evolution of human brain and human intelligence is a very complex task, a very complex endeavor with too many unknowns, too many dependencies, and too many variables. So, will artificial intelligence ever surpass human ability? Timeline, for instance, by the end of this century. Humanity will always create and invent, but the last invention of necessity will be a human-level artificial general intelligent mind. We should be able to create a new super-intelligent, superhuman intelligence and create smarter and smarter versions of itself. It will provide not only needs, basic needs, but a higher echelon of consciousness and intelligence, and will be able to upgrade and to become superhumans. Few experts believe that, for instance, a 50% possibility that artificial intelligence will surpass humans, probably around 45 years from now. That probably artificial intelligence will automate every profession in the world in about 120 years. Although most of the work will be performed by combining, mixing artificial intelligence with human intelligence, what we call hybrid intelligence. Could then AI surpass human intelligence later this decade? We're talking about now decade, not the end of the century, end of the 20th. Well, in terms of certain areas, data analysis, pattern recognition, AI algorithms can process and analyze large amounts of data much quicker, much accurately, making predictions, identifying patterns, that humans may not be able to detect. And this ability can be actually very, very useful in a number of fields like finance, healthcare, transportation, etc. Management, they already being used like that. But another area where actually artificial intelligence may surpass human intelligence is in the complex problem solving. Artificial intelligence can be programmed to solve specific problems, such as optimizing logistics, diagnosing the diseases, etc., by finding accurate solutions, more efficient solutions. And can this be done at a fraction of the time that will take a human being to solve the same problem, with a very high level of accuracy? This applies actually to law, applies to medicine, etc. So we may be able to solve complex problems, and of course, a lot of these will be taken tasks that currently require human intelligence. But what happens then if artificial intelligence surpasses human intelligence? Well, such an artificial intelligence, what we call seed artificial intelligence, because if an artificial intelligence were created with engineering capabilities that match or surpass those of human creators, it will have the potential to autonomously improve its own software, hardware, to design, and even more, to be capable to machine, which could repeat the process, in time. So talking about machines, software, hardware, and we have a chain of creation done by artificial intelligence, by robotics, etc. So it's a debate: human intelligence versus, or not versus, and artificial intelligence. So despite all the data and progress in the field of artificial intelligence, it is now impossible to establish that machines can outperform people and be wiser in all spheres. Nobody can say for sure. Well, there's still a lot of issues and areas we need to analyze and say that artificial intelligence will human brain. Things like emotion detection, creativity. And even if the scientists can useful improving their theory, it will take years to construct an artificial intelligence that could outperform the human intellect, because we are still a very long way from affordable forms of computer intelligence that are as complex as our human brain. So should we augment human intelligence? Yes, not replace it, but augment, yes. Machines seem ready to replicate the work of our minds, not just our bodies. We can actually move from our bodies and augment, amplify our minds. In this century, AI will evolve to be superior to humans in many tasks. But with these trends, it seems like that nothing that cannot soon be automated, meaning that no job is safe for being offloaded to machines. This is the premise that lots of people are working on. I believe, however, that this view and the role of AI will play in the workplace is not totally correct. The question of whether AI will replace human works assumes that artificial intelligence machines and humans have the same qualities, have the same ability, but they do not. Artificial intelligence-based machines are fast, are more accurate, are consistently rational, but they are not intuitive, they are not emotional, they are not sensitive to cultural issues. And this is exactly these abilities that humans possess and which make us much more effective. Things like creativity. Yeah, we're about to finish now. Creativity, now emotions. A machine can be trained to behave like you, but you cannot be trained to develop personality, logical reasoning.
Test.
Yeah? I'm just about to finish. Judgment as well. Humans have a much higher order of thought when it comes to judgment. And of course, intuition. We can run simulations of all kinds in our brains in a matter of seconds. And of course, my last 2 points is the issue, the advance of creating machine learning algorithms and really behind the neuromorphic chips. So incredible revolution that we are having in terms of information. Machine learning algorithms, artificial intelligence are rapidly moving forward, and the power and the promise of this software. So we're talking about patterns and models is huge, immense, beneficial. But along with this impressive advance as well, in terms of software development, there is a parallel evolution in terms of computer hardware to enhance machine intelligence capabilities. And this intensification of technology can be seen in terms of creating the chip, focus on redesigning a much more efficient, lower energy.
1, 2, 3. Test.
Consuming microprocessor chips that mimic, that emulates the human brain circuitry. And the final issue related to that is, as we are more and more evolving into this, the creation of neuromorphic chips are being designed to process human sensory data like images, smell, sound, and to respond to changes in that data in ways that, not specifically programmed. A lot is to be expected to change in terms of machine intelligence, artificial intelligence. That is incredible, that evolution. This is mainly because any effort or initiative of shrinking down the power of a neural network based on physical aspects of human brain onto a single semiconductor chip means that this learning, modeling, pattern recognition algorithms and technology can now be embedded in a wide range of systems in the future, thereby increasing data information capabilities, exponential growth in machine intelligence. And this is expected to fundamentally change the way we gather information and intelligence. And my last joke, my last slide, the human brain is amazing. It functions 24/7 from when we were born and only stops when you take a test or you talk to someone attractive. Thank you so much for being there. Thank you so much for listening to me. And once again, thank you so much for the invitation.